if possible, we can make use of an ergonomic chair to ensure that we have, proper sitting position. So thank you very much. Over to you, Temitope.
All right, thank you so much, Mr. Patrick. That was a good one, and I believe we all listened in, and we should all keep safe and adhere to the safety precautions that have been mentioned. So right now, we'll be moving on to the next agenda. We'll be having our opening remark given to us by our very own section chairman of the SP Worry section, which is Dr. Adetona Oluwaseun. Sir, please confirm you're on the call.
Yeah, good evening.
Good evening, sir. Please proceed.
Can you hear me?
Yes, we can hear you.
Thank you so much for your good work you're doing. Thank you. So, good evening, everyone. YPs, students, everyone. I want to thank you all for taking your time out to be on this call for this technical presentation. Without taking much of our time, I'd like to appreciate this technical lecture facilitator in presence of Engineer Matthew Peters, that we believe is going to deliver this lecture in a way that will be amazing and perfect for us. So on behalf of board and its member, I would like to welcome him on board for his presentation. Please ensure you have your pens, notes. There are many things you will not find outside. These are platform opportunity for you to get them firsthand from the resource person that are involved. These are daily activities. This is what people do with their passion. So thank you all for being on the call. I know many people will still join this call again. So let us enjoy ourselves, sit tight, and enjoy the presentation. Thank you.
Thank you so much, sir, for that lovely opening remark. Like you said, it's not something you can learn just anywhere. So it's a great opportunity. Let's get our pen and papers, because it won't be just the brain. You require the book also to note down things. So thank you so much, sir, for that enlightening and lovely opening remark. Yeah, moving on. Now we are getting to the point in which we've all been waiting for. Be introducing the guest speaker, our guest speaker for the day. Yes. So today on the call we have Mr. Matthew Opuru. He's a process and project engineer at NNPC Gas Infrastructure Company Limited, operating at the forefront of Nigeria's gas infrastructure drive and revolution. With over 5 years of experience across the upstream and midstream sector of the oil and gas industry, this is an amazing feat. Please, let's welcome our guest speaker with virtual applause. I want to see it rolling while I read his profile. Thank you. So, with over 5 years of experience across the upstream and midstream sector of the brownfield of the oil and gas industry, he has played key roles in the rehabilitation and upgrade of brownfield assets, as well as the execution of major greenfield pipeline projects such as the Ajaokuta Kaduna Kano and the Obiafu Oben gas pipelines. This is amazing. He also provides process engineering support for new business opportunity, pipeline tying, and steady state simulation of the NGIC gas pipeline network. Beyond this, Engineer Matthew holds a degree in gas engineering from the University of Port Harcourt. He is proficient in process simulation tools such as IcePen and PipeSim, as well as SQL, Python, and Power BI, leveraging data analytics to enhance operational efficiency and support informed decision making. Please, I'm not seeing the applause. Let's keep it coming. It is not easy to have such amazing profile and experience. His professional interests focus on unlocking and multiply and sorry on unlocking the multiplier effect of natural gas, process safety, and delivering projects within schedule and budget constraints. He is also an economical person. He's a member of the Nigeria Society of Engineers, the Nigeria Gas Association, the Society of Petroleum Engineers, and the Nigeria Society of Chemical Engineers. Beyond his professional responsibilities, Mr. Matthew is passionate about people development and community service. He serves as the church admin for CCI Warri and is deeply committed to mentoring and coaching young engineers. Please, our young engineers and our old engineers as well, please let's keep the applause coming. In his spare times, he pretends to be a mobile photographer, endures the emotional roller coasters of supporting Manchester United. Can we have the Manchester United fans also dropping their applause, please? And he explores new words through books. He is a book reader. So thank you. And I would like to welcome our speaker for today, Mr. Matthew, Engineer Matthew. Please confirm you're on the call, sir. Thank you. I can see the Manchester people still dropping their applauses.
Thank you very much. Please confirm you can see me.
Yes,
you can hear me rather.
We can hear you, sir.
Okay, so I will share my screen shortly.
Thank you.
Do confirm you can see my screen. Can I get a confirmation? All right, thank you very much. Yes, so thank you so much for these opportunities. It's always a privilege to speak to SP, especially Section 104, SP Warri. And I also want to commend the organizers of this program as well as the section chair for his comments. My agenda today is quite simple, and it's to try as much as possible to bring to bear one of the very most important documents we have in the oil and gas industry. I will get into that in a bit. So understanding P&IDs, right? And just to play around that topic, I decided to call it tagging your P's and dotting your I's. So this is going to be more or less like a two-pronged approach, and basically to give us a broad understanding of my intention for this very first presentation is to try as much as possible, considering the fact that I'm sure we have quite an array of different participants. I'll try as much as possible to make it as granular as possible so that everybody can follow along. So the image on just on the screen just shows someone trying to make sense of a P&ID and seems to be really confused about how to do that. And I'm sure a couple of us have encountered that from time to time. So this is my agenda. I'll just segue into an introduction. I will try to make sense of what exactly a P&ID is. Then we'll talk about what importance it plays in the oil and gas industry, as well as other industries as well. We'll look at some industry standards, and then we'll look at some process diagrams. We'll try to make sense of what actually they do entail. And then we'll look at the various types, if we could call them that, of a P&ID. And then we'll look at the P&ID life cycle, which also could be referred to as a P&ID milestone. And then also we'll consider some very key considerations as it relates to designing and developing P&ID as well as take questions as it do come along. So process and instrumentation diagram. So every process plant. So when I mean a process plant, it could be an oil refinery, it could be a gas processing plant, it could even be a wastewater treatment plant. It depends on the network of pipes, whether you're using those pipes to convey or to connect products, and valves, using those valves to control, and also instruments as well that helps you to control. It depends on all of these networks to be able to function safely and efficiently. So piping and instrumentation diagram just stands for, like the name implies, P&ID stands for piping and instrumentation diagram, and it's a detailed representation of a process, and it clearly shows the piping, it shows the valves, it shows instrumentation as well as process equipments, and also notes that details that is required to construct, to design, to operate, and to to safely operate a process plant. So an adage, if we could recall, the adage that goes that a picture is worth 1,000 words. So in a P&ID, you're able to see a lot of information packed in there. So it's important to be able to clearly understand what those information clearly speaks to. So just like Agent 47 for the Gen Zs here, P&IDs also have several names, right? We have the engineering flow diagram, we have the engineering line diagrams, we have mechanical flow diagrams, and we have the process engineering flow scheme, which is an acronym that is common in Shell. And you also have the utility flow diagrams. These are all different names for P&ID. And one thing very important to note about P&ID is that they are often referred to as master documents, because if a change is replicated in a P&ID, what that could mean is that every supporting discipline document may require revision. So most times you happen to see in a engineering review, all of a sudden the process guy says, oh, we need to create an isolation valve for, say, a pump, and all of a sudden that changes your MTO. That changes what the civil guy, in terms of the support that it needs to support that valves and all of that. So they are master documents, like I've mentioned. And so when you talk about a P&ID, what kind of information do you find, do you include, do you hope to see in a P&ID? So on a P&ID, you should be able to see basic operational and startup information. So on the P&ID, you see details like a normal, you see details like a normal operating flow path. On also a P&ID, you're able also to see, you're able also, sorry guys for the noise. You're also able to see a minimum flow protection. So take, for example, on a P&ID, if you have a compressor, you're able to see a compressor anti-surge line on a P&ID. With regards to equipment capacity and rating as well, you're able to see on a P&ID what is known as an equipment tag number. Every equipment. So for example, if you have, let's say 10 tanks, right, floating tanks, say storage tanks in a refinery, right? On a P&ID, you should be able to see tag numbers to differentiate, right? For example, you see something like EK 101, 102, 103 to be able to differentiate them. And also clearly on the P&ID, you're able to see the design pressure of equipment. You're able to see what that the operating pressure would be, and also the design temperature, and also and things like the MDMT, the minimum design metal temperature, and also the maximum allowable working pressure where that applies. So on the P&ID as well, with respect to piping details, you're able to see the line number, because definitely you're going to have different lines, and you're able to see that line number, what the serial number is, what does the nominal pipe size will be. Is it a 12-inch line? Is it 20 inches? Is it 8? You're also able to see what is known as the piping specification or the piping class. So normally you begin to see things like, oh, class 600, if you're referring to a design pressure of about 100 bar, you're able to see class 300 if you're talking about 50 bar, right? And also if there are also insulation requirements, if there are heat tracing and things like that, and also the flow direction. With respect to isolation valves, on the P&ID as well, you could also see details such as your ball valves, your double block and bleed, your emergency shutdown valves, and also your MOVs, your motor operated valves as well as, for example, what is also known as a check valve or a non-return valve. Also, with respect to startup or flushing lines, you're able to see nitrogen purging lines, for example, when you want to carry out your commissioning, temporary strainers, and also commissioning bypass line. And also interconnections, you're able to see how P&IDs move from, because in major plants, you're able to see on the P&ID that for refineries, for example, you have up to like a P&ID that has up to 100 pages. So on that P&ID, you're able to see interconnections that takes from one P&ID, what are also known as connectors, to another P&ID, and sometimes also vendor packages, because for example, you're buying a compressor and you have a vendor package P&ID as well. So without spending so much time on this slide, so safety relief valves, fittings, interlocks, vendor and contractor interface that basically delineates between what a contractor is meant to do and what a package also is meant to come in. And also, for example, your DC inputs like your alarms, your field instruments, your control signals, the signal type, whether they are pneumatic or digital as well. And also information that you're not meant to see on a P&ID. You should not expect to see the pipe route, because even though, yes, you're going to see the pipe, for example, the P&ID will not tell you if there is a 90-degree bend or a 60-degree bend, or even the length of the pipe. We will not expect to see that on a P&ID. Also, with respect to equipment location as well, because you will not, a P&ID is not a diagram that basically shows you a plot plan where equipment are meant to be placed. It just gives you an understanding, a basic understanding of the interconnection that is within equipments. So we're going to touch base on how important P&IDs are, and P&IDs are much important, very much so in every aspect of from the design all the way to operation and maintenance of a plant. So you have, during the design process, it helps coordinate interdisciplinary checks, right, between process engineers and other disciplines, because this forms a P&ID, for example, forms the basis for a line list, right? A line list that basically iterates all of the lines you have in the plants. It basically tells you, oh, this line is coming from the inlet scrubber and is going to the heater. It tells you what it helps as well doing HAZOP, what is known as hazard and operability studies, and also for safety reviews that are very critical to the design process. For procurement, P&IDs provide control details, right? Because from P&ID, you're able to, it specifies instrumentation and control details that are necessary and are needed for obtaining quotes. And these are all informations that helps you in preparing what is known as a material requisition, or also a material takeoff. So they are very much important in procurement. Doing construction as well, along other disciplines, they are very much useful in providing clarity, because even most times when you're constructing, few changes, right? You have, for example, a deliverable that has been approved for construction, and that deliverable is taken to site, and all of a sudden there are few changes that could arise. P&ID helps to be able to record those few changes as what is known as built documentations, and they also help also doing your pre-commissioning stage with respect to hydro tests, and also identifying your drain, your vent points as well. Doing startup, they're also very much important, because P&ID becomes an operational map, right? It basically tells you what the system boundaries are for energization. So you want to start up your plant, you're able to, on the P&ID, say, okay, we're going to start up this section first. And in order for us to do that, let us look on the P&ID, where are we going to isolate in order to restrict our startup to just this section, right? It helps you also to do what is called a valve lineup, to able to know, okay, in order for me to flow gas through this line, I need to open this valve, I need to close this valve, I need to open this other valve, and things like that. And also doing shutdown as well, you're able to see all of the isolation sequence. Okay, we're going to isolate from this part of the plant first. So where are there isolation points to ensure safe depressurization. Also doing plant revamp, right? You have an aging asset, right? And you want to revamp the project. Probably as well, there are new technologies. You want to change and automate your plants. P&ID helps you to be able to identify what your isolation philosophy would be, and also what the debottlenecking opportunities exist as well. And definitely, it also plays a very important role doing the operations and troubleshoot process. Because, for example, doing your maintenance, right? A valve is faulty and you want to replace it. It helps you to do what is called a lockout and a tagout, where basically you're able to isolate and you take that equipment out of service as well. So the next thing we touched based on it was communication too. So why is very much important. Most often than not, yes, the P&ID is a process deliverable, is being developed by a process engineer, but then again, it's not done in isolation because as very much important as well, it serves as a communication tool where it brings the process, it brings the mechanical, it brings the instrumentation, and it brings everybody to the table because also P&ID is an input to every other EPC discipline. So for example, for a piping or a mechanical engineer, it needs the P&ID to be able to develop a 3D piping model, right? It needs a P&ID to develop the ISO drawings that will be useful for fabrication and construction, and also as well as the equipment and the valve data sheets. For a process engineer, we'll take feedback from the P&ID and create what is called a cause and an effect diagram. For the instrumentation and control, it will develop engineering drawings and also the logic narratives. We're talking about the input and output list. And then you talk about I've mentioned just for time, the HSC will use that, the P&ID as a input into a hazard or also a hazard identification report. So in terms of industry standards, right? So the most common standard is the ANSI and the ISA. That's the Institute of the International Society of Automation 5.1 instrumentation symbols and identification. It's important to note that there are numerous standards, just as you can be able to see from the diagram on the right-hand side, that are developed for creating P&IDs. So there is no generally acceptable universal standards. It's very important to note this because most times you pick up an P&ID that is done by company A, and you compare that against a P&ID that is done for company B, and you discover that there is discrepancy because even sometimes within organizations, within a company, P&IDs can look different from company to company. And sometimes it depends on the type of software that is being used, or sometimes also the preference of the creator. So for example, if you're using AutoCAD P&ID, right, and you want to select a pump, it gives you more or less like different graphics. And I prefer pump A better, and I just pick that out. So it's important to note that while yes, the ISA 5.1 is common, and there are also other numerous standards as well. So just to touch base on some process deliverables. So before we get to P&ID though, there is what is known as the BFD. Is called the block flow diagram. And on the block flow diagram, major equipments, processes or unit operations are basically just represented as blocks, right? So BFDs are very useful tools because it gives you a feel for the process, right? And most times you use BFD doing conceptual design. You're just trying to represent one or more process units. You're trying to explain a process to management. So it's very useful in conceptualizing new processes and basically explaining the main features of a process. And it's very important because it provides a simplified starting point for going on to prepare a process flow diagram, and also what is also called the heat and material balance. And we'll go off. So by the time you're done preparing that, you'll now go into the next diagram that now takes in more details, which is called a process flow diagram. So a process flow diagram is a quantum leap, right, in terms of the information that is provided when it's compared to a block flow diagram. So you see on the process flow diagram, it shows the major relationships between major components in the system. So the diagram on the right-hand side just shows the absorption process with respect to, in the very late term, right? You have sour gas, that are acid gases, H2S and CO2, and you pass that into the absorber here, and then you pass in what is called a liquid desiccant, in this case a lean admin, and that has a countercurrent interaction with your sour gas and takes out your sweet gas from the process. So it's just a PFD, right? It just shows your major process parameters, how they are going to be controlled. So that's why this just shows your major groups majorly. And also on the PFD as well, you're also able to see your stream information, right? So sometimes you see them represented as 1, as 2, and that also helps you to be able to develop your heat and material balance, because it tells you, the sour gas comes in, this is the temperature at which it comes in, this is the pressure, this is the composition, And by the time it comes out as stream 2, oh, sweet gas, this is the composition, this is the temperature, and this is the pressure, and other informations like that. So just to bring everything home, right? So you have an example here of a heat exchanger E1, right? On the BFD, it's shown just as, like I've explained, it's shown just as a block. And when you take that information further as a process flow diagram, you're able to see an icon that basically represents an heat exchanger E1. And by the time you take that further into what is known as the piping and instrumentation diagram, you're able now to see the drain point, you're able to see the 12-inch isolation valves upstream and downstream of the heat exchanger. You're able to see the PSV, the pressure safety valve, that is set at 150 psi, and you actually also do have the tailpipe at the 6-inch valve that is car seal open, right? And so all of those information, so it just gives you more or less like a systematic differentiation between these three diagrams. So just going to just try to make sense of the difference between a PFD and a P&ID, because this point is very important to note. And just to confirm, I've not lost the audience, right? You guys can still hear me. All right, thank you.
Yes, we can.
Yeah, we can hear you.
So the difference between a process flow diagram and a P&ID. So we'll look at the goal during the project design, right? So the PFD most at times is a process engineering internal document, and most times is for management decision. You're trying to explain the process to management and also to get regulatory approval, right, with NNDPRA. And with respect to the P&ID, the P&ID is a link between process group and other design groups. And doing plant operations, you can pick up the P&ID because it gives you a general idea of the plant to the plant operations team. But when you want to carry out, for example, maintenance, right, you will not use the PFD, you will use the P&ID because it clearly will now show you all of the isolation valves, or what the manual depressurization of the station would be, or what are even the granular details as to the design ratings or the design pressure, operating pressure of specific equipments. Also, like I mentioned, PFD just shows the process steps, like the absorption process I just showed. It shows you those process steps and some control loops, right? But for the P&ID, it will show you all of the mechanical items and all of the control loops and interlock functions. So, for example, you have your control loop when you're talking about the final elements and the logic solver and all of that. You're able to see all of that information captured on a P&ID. And with respect to how they look, right, different symbols that are connected to each other by some lines. So on the PFD, you have streams that basically shows the connection between different equipments. However, on the P&ID, you now have lines that represent pipes, right, that connects from one symbol to the next. So with respect to P&IDs, right, there are different types of P&IDs. And it's very much important to note this because most often than not, if this is not well understood, it makes reading a P&ID very much difficult. So one thing that is very important before you jump into reading a P&ID, just for example, you take your Google Map, for example, and Google Map is quite intuitive that it tells you turn left, turn right at 400 degrees, 400 meters, do this, right? So for every P&ID, there's what is normally known as a legend sheet or a legend P&ID. It basically just shows you each symbol that is used on the P&ID, as well as also abbreviations as well. So sometimes you see certain abbreviations that are written against equipment or on lines on the P&ID. So sometimes you see something like FO, NO. So for example, FO will mean fail open, FC will mean fail close, normally closed, and things like that. So it's important to consult the legend P&ID because it clearly shows you all of the symbols that are used. Mind you, I mentioned the fact that different organizations have different symbols. So by the time you consult this, you're able to know what symbols what they mean without actually guessing. So there's also what is known as the typical details P&ID. So most times you happen to have, let's say in a very large refinery, for example, in a plant, you happen to have, let's say a drain point, right? And then that appears in like 100 places, right? You don't want a scenario whereby you repeat that so many times that it takes up so much space, because yes, the P&ID is meant to be kept as concise as possible, not crowded. So sometimes you have a typical details P&ID that are used for consistent arrangements. So basically you just repeat it once, and then every other occurrence of that arrangement, you just basically refer to that typical details and P&ID. We also know what is known as distribution P&IDs, and it just basically speaks to, we're talking about distribution of services. You're talking about steam, cooling water, compressed air throughout your plant, all of the utilities, effluent headers, and how they are distributed. They are called distribution, or sometimes called utility P&IDs. Then you have a tie-in P&IDs that basically are used to differentiate new scope from an existing plant. So you have a tie-in, you're bringing a new scope into a plant that is already existing. So you already have this represented by either a box or a cloud to basically represent those new connections. Then you have what is known as the package P&ID. So these are vendor supplied packages. So you have gas dehydration units, you have compressor packages. All of these are represented on the package P&ID. So we'll just go on to another details, which just basically speaks to the P&ID life cycle, right? And it's very important to understand that P&IDs are designed in steps. So there are various steps in which P&IDs are designed. They are, like I mentioned, they are controlled documents that are formally issued at various stages, because changes that are made to the P&ID needs to be identified and documented, because it should be able to follow through a formal process. And this occurs several times in the course of a project. So the first stage of issue of a P&ID is what is known as issued for review, or sometimes also called issued for planning. So at this stage, you have preliminary review and a feedback from various stakeholders, from the client. For example, an EPC, an engineering, procurement, and construction firm submits a P&ID to the client, and the client reviews that. All right, so please, if you're not speaking, you can mute your mic. The next, like I mentioned, so on the issued for review, the primary P&IDs are issued and the plant reviews them. So these P&IDs basically represents more or less like the first thoughts, the very first thoughts about a plant, and it is used as a very starting point, for example. So for something, for example, issued for review, we begin to have conversations around, okay, for this water bath heater, for example, for this heat exchanger, do we want a single isolation valve, or do we want a double isolation valve? Okay, with respect to the compressor, the piping spec, for example, is it going to be a class 3 600 in terms of, okay, the design pressure, is it going to be 100 bar, or is it going to be class 900? The design pressure, is it up to like 120 bar, for example? So that's information you would necessary conversations that happen during the issued for review. And at the end of that process, what now happens is that after the client, I beg your pardon, has reviewed the IFRO version of the P&ID, they basically do what is called a markup. They mark up that P&IDs with their thoughts and also their requirements as well. The engineering firm will now go ahead to implement or also address the client's recommendations or even comments. But it's important to note that this process is not just a process where the client says jump, right, and the engineering firm jumps. Sometimes that comes with conversations, that even comes with suggestions, and sometimes there's a lot of conversations, a lot of back and forth. But at the end of this process, the P&IDs are presented to the client, and then the client approves them, and then it goes on to the next stage, which is issued for design. So the issued for design is crucial because it is a very needed document for design review and also what is known as a hazard and operability study. So the P&ID at this stage is used to identify potential hazards and operational issues that may arise to ensure that the plant is safe. So most times this P&ID is subjected to a third-party review. You get a HAZOP certified chairman that comes in to review your P&ID. And at the end of the process, you have recommendations as to, oh, you need additional safety valves, or you need to change the piping spec. And also, this stage as well, is also important that all of the vendor informations they are going to be getting from the vendor should have been available at this stage. And then the next stage as well is issued for construction. So this is a final version of their P&ID that will be used during construction. And the P&ID basically at this stage is what is now used to build the plant according to the approved design. So it's a very crucial document that it's important that the plant is built accurately and according to design specifications. Like I've mentioned earlier, so during the construction phase as well, there might be changes that might happen, and those changes needs to be documented because properly documented, because most times they might force other engineers or even contractors to even redo their work, sometimes causing delays and also variation or additional costs. So the next P&ID we talked based, the last step is what is known as the as-built P&ID. Some organizations call it issued for record. So after construction is completed, the P&ID is updated to basically represent as built, as the plant is built, the condition that at the end of construction. So it serves as a record of the actual plant configuration. And this information is now what is used for maintenance modification. So imagine a scenario whereby the as-built is not documented and someone wants to operate the plant and picks up the approved for construction. And all of a sudden you find out that, oh, this valve that is being showed on the P&ID is not there, only for you to realize later that, oh, during the construction phase, right, they discovered that it was no longer needed and they took that out. So before we go, so what are some of the key considerations that if there's anything I want participants to take out of this lecture is with respect to these key considerations. Number one is that P&ID is a conceptual drawing, right? And what that means is that it is not drawn to scale. It is not drawn as to geometry. So, however, it should represent reality as much as possible. And what I mean by that is basically, for example, I have a 12-inch valve, right, that is connected to, say, a tank that can be able to store 10,000 liters of crude. I will not, while designing developing my P&ID, I will not do the valve to be as big as the tank. No, right? But that as well, I also will not draw it according to scale because it's a conceptual drawing. Another thing as well, which is respect to documentation. So this is very, very key. All changes should be properly documented, including the reason for the change and the date of the revision. Why this is important is because just imagine if, for example, you are a piping engineer and you pick up an old P&ID, for example, a P&ID that is not up to date, and you use that, you spend, let's say, 2,000 man hours developing isometric drawings, only to find out in the process, right, that, oh, is an outdated document that the process engineer sends to you. In local parlance, you will tear somebody's shirts, right? So changes should be documented. It's important that P&IDs undergo what is known as a management of change, a proper management of change process. And thirdly, it is not definite. So they do not include complete specs for all equipment in the process. So even though, yes, for example, P&ID has information relating to a plant, for example, they do not contain all of the necessary information. So for example, even though, yes, I've mentioned that it is useful for operation and maintenance, it's important to note as well that if I want to do operations and maintenance, I will not rely on the P&ID alone. I will pick up, for example, a control and operating philosophy deliverable, for example, and other documents as well, very much important. So also, like I mentioned as well, they are not drawn consistently. They might appear differently on the internal standard software system and also the creator's preferences. So if you pick up a PNID and you see that PNID A is different from PNID B, it doesn't necessarily mean that either of them do not know actually what they are doing. It depends on the standards in which they have adopted. So a takeaway. So I would just want to say avoid what is known as the Piper's trap. And this is oftentimes a struggle between a process engineer and a piping engineer, although we're very good friends anyway. But sometimes a process engineer is saying, I see 6, and a piping engineer is saying, I see 9. I will leave that to the audience to tell me who is correct. But process, for example, will ask a piping engineer, why didn't you design it like the PNID? And the piping engineer will say, oh, the PNID is just a conceptual drawing. And an example of this is, for example, on the PNID, you have a drain, right? A drain that is shown basically to, in a layman term, basically to take out liquid from, say, your filter separator, right? That is shown at the bottom of the vessel. It is shown at the bottom of the vessel on the PNID. But in reality, right, the piping engineer has designed that to be routed upward when normally it should be routed downward because you want to be able to utilize gravity to drain out the content in your filter separator. So if it is routed upward, what that means is that the liquid will get trapped, right? And then as well, another question as well, the process is saying, why did you design it this way? And the piping is saying, oh, I designed it just like the PNID showed, right? So for example, you have on the PNID, a control valve, for example, is placed correctly in line, but actually in the layout, it is located between a pipe rack beam where you have a lot of beam, and then there's no space actually to even remove the actuator, right? To even operate the valve. That's going to be an operational nightmare. So it's important to note that at every given point in time, the principle in developing documents should be to preserve process intent while ensuring that the physical feasibilities are always respected. Thank you very much.
Thank you very much, sir. Thank you, Engineer Matthew. Please let's keep our applause coming. He has enlightened us a lot today. I think the first thing is for us to also remember that the piping and instrumentation diagram is a representation of your plant, of your facilities, and it shows your valves, it shows your equipment, everything. And I believe we've learned a lot. So I don't want us to just go home with all our questions on our mind. So we'd like to take our questions now. If you have a question, you kindly raise your hand or you drop it on the chat box and then I read it out for him to answer. I believe we have questions. Yes, thank you. I've seen our applause. Thank you for the wonderful and awesome presentation, Engineer Matthew. So over now, we'll move to the question and answer session. Next slide, please. I can see some questions. Some people are asking if they can get the material, the presentation slide. Engineer Matthew, kindly confirm if that is possible.
Oh yes, absolutely possible. Okay, so I can just attach it to the meeting chat so that every participant can be able to get it in real time.
Okay. And I just noticed we have our immediate past council chair on the call, in person of Mrs. Amina Damandani. Ma, kindly say hello to us.
Hello, good evening.
Good evening, ma'am. We're happy to have you on the call. Thank you for joining.
You're most welcome. It's a very interesting topic. So I made sure I attended because I'm very interested in it. It was well delivered and very insightful and educative. Thank you very much. But I missed the earlier part. So that's why I don't want to ask any question in case he has already addressed it and I was not there. But maybe there'll be an opportunity to send a private question to him so that I don't pull us back. Thank you very much and well done. This is really a good one.
Thank you,
much.
Thank you, ma'am. Okay, so I think there is a question, or rather, I'll say the contribution. The person asks if okay, sorry, I missed one. Okay, I think I saw one on where if we could have a little demo on how to read the P&ID. Would that be possible, sir?
All right. So as mentioned during the beginning of the lecture, I did mention that this is a two-part presentation. The first basically is to provide basic information to bring everybody up to speed, and then as well you have a second part now that is now meant to build up on the initial knowledge, and that will now basically dovetail into like a practical session where we just delve into a P&ID and try to make sense of it.
All right, thank you. So there's more to come. Stretch your eyes, and so just look out for more exciting parts, which has to do with reading it. So we also have this question on which document contains HMB and fluid composition. Is it P&ID or is it process flow diagram? Which owns the P&ID document, process engineer or the drafters? Did you get that, sir?
Oh yes, I did. So with respect to the heat and material balance, right? So it depends on the organization. So for the organization where I work with, you happen to have that as a standalone document in most cases. But sometimes as well, also it depends on the nature of the project. So for example, if you just have, let's say, you're trying to connect you're trying to tie into an existing pipeline, and basically it just entails having a pipeline and a valve for isolation purposes, right? Very, very short project in terms of the details. All of the information with respect to the heat and material balance will now be captured on the PFD and not on the P&ID. So you're able to see all of the fluid composition. You're able to see how those fluid composition changes with respect to how it transverses through equipments. So you see that on the process flow diagram. And then on your second question on who owns the P&ID document, so as well, it also depends on an organization. Some might call it a drafter, all right? But at the end of the day, basically, whether a process engineer or a drafter, both must have very strong understanding of what they are designing and also how it accurately details the process, so to speak. I hope that answered Kingsley's question. So I can see another question there. If I can just take.
Yes, please go ahead, sir.
Okay, so the question from Suleiman is asking, as a GT, what would I suggest one would build a career in? So I would say that I won't suggest either, but one thing I would tell you for free is that even as a process engineer, I'm well versed in piping engineering as well. Because remember when I mentioned that the P&ID is a communication tool. By the time a P&ID is developed, whether you developed it yourself or you're reviewing it, for example, by the time you come into a design meeting, you're going to have a piping engineer there. And it's very much expected that you're able to clearly articulate and communicate the reason behind the P&ID and also take feedback. So that also means having a very, very good understanding of pipeline engineering as well, because even in respect to piping and the flange rating, for example, you need to be able to hold your ground. But I also add as well, it boils down to interest as well, right? What are you interested in? What is also with respect to your area of expertise, right? Because most times you happen to see a chemical engineer more or less drift to process, and you have your mechanical engineer basically find home in piping engineering. So Sylvia is asking for a new pipeline engineer. What should I check alongside the P&ID before using it for any pipeline design or tie-in works? So why P&ID is a very important tool, is also important to note as well for piping design as well. P&ID is more or less like an input, because, for example, on the P&ID, you're able to see what the line size is. But alongside that, there's also other items like, for example, you have your alignment sheets that basically articulates the route of your pipeline, the depth of cover in terms of when you lay your pipeline in the ground, the location class, the thickness information, the coating informations. So in addition to that as well, you're able to see the alignment sheet, also your tie-in P&ID that also tells you where you tie in, either you're doing a cold tap or a hot tap as well. Salem is asking, what are the deliverables for a process engineer? So apart from the PFD, the process flow diagram, the piping and instrumentation diagram, you also have the heat and material balance. You have the cause and effect diagram as well. Off the top of my head, there are also other deliverables that I can't seem to recall at the moment. Oh, you also have the operating and control philosophy that sometimes a process engineer also develops alongside other disciplines. So I think that's pretty much the questions. I think other comments that have been included in the chat. Thank you.
All right, thank you very much, sir. Did we take Francis' question? We've not taken Francis' question yet. P&ID also prevent process safety incident on site. Okay, it's a contribution. All right, thank you very much, sir. So we've come to the end of the question and answer session. Thank you all for your questions, and I hope we got our answers. Right now, we'll be moving on to the photograph session. Please, let's turn on our cameras for the photograph section.
Kemi?
Yes, please go ahead.
Did you check the announcements or until after the session, photograph?
After the photograph session.
Okay. All right. Can you be able to do that, or I should do it from my end?
Okay, please, you can go ahead from your end. Thank
you. Okay, guys. As communicated by Temi, let's kindly switch on our videos.
Let us switch on our cameras. Want to see our beautiful faces representing SP from different places.
Wow. Okay. All right. Thank you, guys.
Yeah, thank you.
So has he dropped
has
he dropped the document? The document?
The presentation.
He said he was going to share the presentation.
He's here to drop it.
Yes, he's here to do that, but
okay, but maybe you guys can forward it to us as well.
Yeah.
And then
definitely.
if we want to reach out to the instructor, do I call him instructor now? Lecturer. How do we do that?
Facilitator.
Facilitator.
He will as well to do well to drop his contact details.
Okay, thank you.
Yes. And this is just the teaser that we have part 2 of this coming up in July, second week of July.
Okay.
So we'll do well to send a reminder for you.
Yes, please.
So
please, I'll be happy to join
thank
that
you.
too. Thank you very much.
Okay, thank you. All right, over to you, Temi.
All right, thank you very much. We're all happy to see our faces. And as mentioned, we'll be having the part 2, or the other part of this session, which will be in July, the second week of July. And I hope we all attend, because then we'll get to see a more practical session. So let's all attend. And for announcements, the SP Warrior section will be having her annual general meeting on the 18th of July. So let's prepare and be there. It promises to be insightful and everything you can think about. Lovely and of course educative. Yes, so thank you. All right, moving on to the next thing on our agenda today should be the closing remark and the vote of thanks, which will be taken by our program's chairperson in XP Warrior section, in person of Engineer Elvis Duriji. Sir, please confirm you're on the call.
Yes, I'm on the call. Confirm if you can hear me.
Yes, we can. You can proceed, sir.
Loud and clear.
Okay, thank you so much. It's another wonderful presentation. It was quite high level of expectation, and honestly, the facilitator, Mr. Matthew, Engineer Matthew, really delivered. I want to really appreciate our immediate past council chair. We are so honored. In fact, when she sent me, gave me the clue, sent me the advert that shows a lot of interest that she's coming in, I was so pleased. I want to really appreciate her coming in here. And again, I want to thank everyone that have participated, even the organizers, directors, our directors here present, the session chair, on his behalf, in whom I am making this thanksgiving and appreciation. I want to appreciate everyone. This is just the part 1. I want to promise every one of us, this P&ID is highly needed everywhere, even in NMDPRA, there's regulators. All the licenses and approvals are closely tied to all the various, whether it's the PFD and all that, whether it's the preview, the license to establish, where that's the feed, front-end engineering design. There's a special kind of P&ID, the process flow that is expected to guide that. Before a regulator gives you a license, you need that. Or you want to give you a license to construct, you need the P&ID, detailed engineering design. That is the tool on which basis the regulator gives those licenses. Then the as-built. Even there are a lot of reviews the regulators carry out. Whereas the fact he mentioned that the 60-degree completion at the during construction, 30% review, all these you carry out, you use the P&ID to implement all these stages. Then as built, or package vendor, whichever way, it's all throughout the life. Even turnaround maintenance, some years after the plant is operating, all the maintenance you're carrying out, you read this P&ID, both from the drafting to the technologies that will be involved in the construction works. Everybody needs to. It's a tool for everybody. Whether you're a technologist, you're an engineer, you are maintenance and whatever, it's something very important. So I want to ask everybody, particularly students, and I'm very sure the next one that is coming up in July, we are going to have massive people that will join. It's quite interesting for me. I was living in nostalgia. I had to, a couple of things I've done in the past, I was so impressed. You have to bring me back to memory lane as a regulator. So thank you so much, Engineer Matthew. We are looking forward to having you back. I want to thank all the students. I'm sure those people that are not here today, you will have missed a lot. Please, let's go back and highlight the message. Tell everyone, please, you're missing something. If you are an engineer, you are working with the oil and gas, come and get this information because it's very, very important. So I'll bring the curtain to a close and once more again, appreciate the organizers. God bless you all and have a wonderful night. Thank you.
Thank you very much, sir. Good night, everyone.
Yeah, thank you, everyone. Thank you all for joining. See you in July.
So the presentation has been dropped on the chat as well as my LinkedIn link as well for follow-up questions.
Yes, please let's take note of that. The presentation is now on the chat box.
Please, Secretariat, do not end the meeting immediately. Give at least 5 more minutes so that people will be able to download the slides and take note of his contact. Thank you.
Boss, please, can you equally help us to pick it up and put it in our group? In our
Yes, sir.
Yes, please, so that we can have access. Thank you.
Thank you, boss.